It's a beautiful sunny day in Santa Cruz, and we're doing something special today. We're gonna head up to Oakland, California, which is about an hour away if we're lucky with traffic, and we're gonna visit Enduro Bearings. I've been invited up to check out the facility, meet Matt, Harvey, and the gang, and learn more about their full lineup of bearings. They make industrial bearings and bicycle bearings, and they've been in business for almost 30 years now. So it'll be fun to see their facility and learn more about their incredible lineup of bearings. As we head to Oakland, it's my chance to tell you that this will be a longer video, so I'll put chapters at the bottom of the video that let you easily find and go to whatever interests you most. We are here! Enduro's USA Operations Manager, Dustin Long, met us at the door, and I immediately spotted the spectacular vintage bikes on display. Is this Matt's collection, or?
Yeah, so this particular area is a timeline. Almost, right? Like earliest, and Matt couldn't give you the whole breakdown of each bike. I cannot. But that's an old, like, you know, Cambio Corsa bike.
Sure.
And yeah, it just kind of goes down the timeline, and then there's like a race bike on the other side of this wall, and they go around the corner here too. Yeah, I mean, you probably, I'm sure you know, Matt spent a lot of years at Bianchi
and Fisher.
At Fisher, at White Industries, and
This is quite a collection.
oh yeah, it's good. That Mercier, that's, I believe that's a Pro Tour bike there. Matt, I can never remember whose bike it is, but he knows.
Look at all this stuff.
Oh yeah.
So this is the warehouse.
Yep, millions of bearings in here.
Hi, Matt.
How are you, Jim?
Good.
I figure we must have met at some point.
Yeah, I met at Sea Otter.
Oh, okay,
Nick
right.
brought me over and he was showing off the Max tester.
Oh, okay,
Tester.
okay, yeah.
I was really impressed with these Bianchis.
Oh, yeah.
Beautiful.
Yeah, I was collecting for a while and tried to cure myself for that. But,
It's hard to find those old Bianchis.
I know,
Those
I
are
know.
very valuable bikes.
Yeah, that one at the end, that Cambio Corsa one, it's rare because it's original paint.
People talk about how hard it is to shift them, but I mean, they could do it back in the day.
Yeah, I mean, they've practiced enough. I mean, supposedly Gino Bartoli could shift it while he was sprinting and climbing hills.
Wow.
There's these stories, but
Yeah.
maybe you could. I mean, if you ride it enough,
Yeah.
you're on the bike for 10 hours a day. You
Yeah.
figure out how to do all that. So yeah, that one's 1947, and then 1952, and then this is Giamundi's era. I think it's 73 or 74. And then this one's 1981. Kind of my era when I started working at Bianchi.
So you know how they came up with that color, Celeste or Celeste?
Yeah, I've heard several stories. One is they mixed up all the paint after World War I, and this is the color they got, which I would think it would probably be brown. That's one story. And then it's the color of the sky in Milan, in the Po Valley.
A certain part of Milan.
But and then you see how it's changed. Like that one's really kind of got a yellowish.
Yeah.
And
Very different.
The clear coat gets old though, and it yellows, and it changes the color too. So
Yeah.
the color, but this one is definitely bluer. And I think this one, you know, this bike was repainted at a bike shop. Maybe they would give you paint to freshen them up, and decals. I guess was common. Sorry, I'll go down the rabbit hole.
No, they're very cool. There's Rick.
Jimmy.
How are you?
Good, how are you?
We'll go over there. The main building is across the parking lot, and we refurbished.
ABI Bearings.
Yeah,
Yeah.
ABI Industries, and then we refurbished this building, which was a World War II building. 7-Up used. This was all 7-Up property. 7-Up bottling company. This was their vending machine repair building. And it's a World War II building, a metal building that was moved here, probably in the 50s.
And you guys, you've been here since '96, or?
No, since around 2002, we moved here. We were down towards the middle of town before that, in another old building,
Oh.
a meat packing plant. And we went from meat packing to 7-Up.
You're upgraded.
Yeah, Miller Meats. But so we took us a year to refurbish this building. It came out really great.
Well, we have to talk about the history of bearings because it's kind
Yeah.
of fascinating, you think about it. I keep thinking back, I started, and you probably started at the same time, everything was cup and cone bearings.
Yep. Yeah.
And then today, you don't even think about your bearings. We used to tell people overhaul your bike once a year.
Yeah.
And you'd pay for it. Big process. Back then it
Yeah.
wasn't that expensive, but today
Yeah.
they could charge you a couple $100 if they had to do all that.
Oh yeah.
But
A lot of work.
now you can almost take bearings for granted because they're so well designed, and so you get a lot to do with that. And
Sometimes, yeah. I mean, people still spec sort of undersized cartridge bearings a lot, but that keeps us in business to make some improvements, of course, too. But yeah, you're right. Everything was cup and cone.
yeah,
So and the stuff lasted a long time. I mean, I remember replacing cones and repacking them, of course, and everything. But the only cartridge bearing components I remember when I started was fill wood stuff and maybe some older SKF bottom brackets.
Maxicar out of
Maxicar.
France.
Yep. Yeah, they were uncommon. But then about when I started, things were really switching to cartridge bearings in hubs with the mountain bike boom, with ringlay hubs, TNT, White Industries, all of that.
Specialized came out with a whole line of hubs with sealed bearings.
Yeah, and bottom brackets, like when I was at Fisher, they were using, Fisher mountain bikes, they were using 6003 cartridge bearings in the bottom bracket, and Fat Chance, they were using the mini bike, I call it the mini bike bearing because they were using Briggs and Stratton engines. But,
Oh wow, out of an engine.
that was for bottom bracket bearings, but we still have those for replacement if somebody needs them. But
That's a good question. How many different bearings do you have?
Over 200 bottom bracket skis.
Yeah.
Just bottom brackets.
Wow.
Over 200.
and bearings, different specifications, sizes, etc. It's about almost 2,000 different sizes.
Wow.
Which, if you had asked me in the beginning how many you really need, I'd say like 20 or 30. But here we are, maybe 50. But just headset bearings alone, we have about 70 different sizes. I was just looking, different specifications and sizes.
Is this stuff manufactured here? You have another facility in Singapore?
Yeah,
Yeah.
Singapore and Shanghai.
Shanghai.
So we did have a California facility up until a couple of years ago through COVID and making XD-15 bearings here. But we've moved those over to Asia now too. We do some things still here, but yeah, making bearings full factory, it's a huge investment. You got to keep it busy.
All the components of the bearings are individually made. The races, the balls,
Yeah.
each thing is an individual thing, and then it has to be assembled. So
Yeah, so for instance, nobody's making, like, we wouldn't be making balls even if we had a factory. The balls are made at huge factories. We buy them from Toshiba in Japan, all the bearings for our industrial side and ceramic. And so there's huge factories that just make balls.
just make balls.
And then there's factories that just make the seals and factories that just make the ball retainers, for instance. So usually when you're talking about a bearing factory, you're talking about making the races, the inner and outer race, the tracks that the balls roll on, and then assembly, heat treating, of course, for that, and final tasks, and then assembly and quality control. Yeah, that's what the bearing factory did.
So the race is pressed into the balls. The balls put in separately.
The balls are put in, so they're assembled, most bearings are assembled what they call Conrad style. And this guy Conrad patented the process.
Okay.
So you put all the balls into one side asymmetrically, and then you roll them around. So you put the inner race all the way to one side, and then you you can feed all the balls, a certain number of them.
Yeah.
Let's say about 50% of the bearing you can get balls in, and then you snap it together and you roll them all around. And that's why there's a retainer to keep that spacing even all the way around once you get the balls assembled in there.
Interesting.
That's what I do at Christmas. I assemble
Really?
Campagnolo bearings in my house.
Oh, it's fun.
Yeah.
Everybody in the company has their little pet projects. And I remember learning about Matt. You know, he sent me a video one weekend. Like it's summertime. He's sitting out on his patio, and he's just putting together Campagnolo. Because there aren't too many on scale. We don't sell a ton of high-end XD-15 Campy BBs, and he's still. If you buy one, the boss put it together.
I put it together, yeah.
That's cool.
Yeah, so those, like for instance, we finished processing here. Again, it's hard. You never see all of the processes done in one bearing factory. Usually, it's several processes that come together. But for high volume bearings, you would have an assembly machinery about the length of this aisle right here.
Wow.
So let's say 100 feet, where you have races and balls and components going in at the beginning and final assembly bearings coming out at the end. All done, but it's all done by automatic equipment, measuring and putting the balls in, getting the right clearance, checking them, everything.
Not done by hand, it's done by machines.
No, we do, like our max bearings are done by hand. Those are the full complement bearings for suspension bikes. So there's no automatic equipment for those types.
Those are the lifetime, well, the XD-15s and the Max Hit are
No,
lifetime.
those are retainer bearings as well. But max type bearings, suspension pivot, full complement. So there's no retainer in it. It's just
Oh, it's solid?
just
Yeah.
filled with balls.
Yeah.
And those are for suspension pivots. And the assembly process on those is completely different.
One of the unique things with Enduro is that, given Matt's affinity to cycling, we do have an industrial division, as you know, but he focuses on cycling only. And each bearing for each location on the bike has a unique design, and each seal for each bearing is uniquely drawn and designed, because the friction on us, if you just scale the seal, the friction would be very high in a bottom bracket bearing because of surface contact area. So Matt's actually gone in, and each seal on both sides of each bearing of the 2,000 bearings we have, he's actually put the thought into how dimensionally that seal should be designed to work at that particular diameter.
You have a rear hub, for instance, and there's 4 bearings, so there's 8 seals in there, and they add up. The friction adds up, so you have to be really conscious of, that there's 4 of them in a rear hub, 2 in a front hub. So, yeah, every bearing the seals are designed for each size, every size.
To try to make sure they're as efficient as possible.
Yeah, it's a compromise between sealing power and friction.
If you take suspension bearings and headset bearings and you set them to the side just for the moment, if you take the bearings that are actually do full rotational spins on a bike, pedals, bottom bracket, hubs, you've got 12 rotating elements in the bike. 6 hub bearings, 2 bottom bracket bearings, and hopefully 4 pedal bearings. And then
You do pedal bearings too?
Yeah. Yeah, we do needle bearings. Often they're needle bearings and ball bearings. So, yeah.
Like a look feel pedal, you could upgrade the pedal, the
Yes.
bearings in the look feel
Yes,
pedal?
we have those.
That's cool.
And this is Alex Wassmann.
Oh,
You may have
wow.
met Alex.
He knows what, hi Alex, how you doing? Nice to meet you. This is my wife Deb and the camera. Welcome.
Thank you.
You guys want to get out of the cold for a minute?
So we remodeled this office about same time, about a year and a half, 2 years ago, and it was it's another metal building, as you can see. So we kept the structure and just framed in all around it, and yeah, we made our the bicycle division here, bicycle office. I was lucky he was working with a really good creative guy who helped me with everything. Kind of have a history of bearings here.
Yeah.
I like this. Here you go. So this is how I started. We were buying and selling old stock of bearings that we would find at machine shops and different places. And these are from World War II. This one's still in the can in the oil. So you could open that up with your can opener and it still would be fresh as a daisy. And then this one's,
Look at the size of that thing.
yeah,
Wow.
it's, I don't know what
Wrapped
it's
in
for,
wax?
but it's also wax and foil, and it's still got the military number on there. And
What would that go in? A tank?
it could be a wheel assembly, probably. It could be some motor bearing. It's got a snap ring on it, a locator, so it could be some final, probably a drive bearing because of the snap ring, a shaft. All these things kind of, they're standard and they fit many different things. But yeah, these are surplus bearings that, you know, they're older than me, but you could still pull them out of here and they'd work like day one.
That's cool.
So that's, and then some other things we made through the years. Even I always like this one here, which is a double tapered roller bearing for a Volkswagen transmission. These guys that make hot rod sand buggies, they want this one. Usually it's a ball bearing, but this is a double tapered roller bearing, so it can take 600 horsepower, and it threads into the transmission. So, you know, you see here, like we made a threaded bearing recently. There's a lot of crossover and everything, and you get ideas, but we had to do special heat treatment for this so it could withstand the rolling resistance, but also not break.
What's that bearing cost?
This is about retail. This would be about $100 or $150.
Not very expensive.
Not really, and it has a custom ball. Everything automotive is less expensive usually, but it's got a custom spacer you have to make for each bearing to get the preload exactly correct. So, you know, a lot of these things add up to just ideas in my head that help create things like Max Hit, because this isn't that much different when you look at it. This is a T47 bearing, and you look at that, they both have splines. This is, of course, a tapered roller bearing, but it's a threaded bearing. It has to do two things. It has to be tough enough not to break when you thread it in, and it also has to be hard enough to roll balls on it. So it's the same solution for both of these.
When he was at Bianchi, it's the Johan Museeuw Paris-Roubaix bike.
Oh, yeah.
This is a duplicate. It's not the bike.
The famous bike.
Yeah.
Full suspension Paris-Roubaix way back.
Yeah, so when Matt designed this, he was the mountain bike product manager at Bianchi.
This was before he got crazy about bearings.
Yeah. Just before.
Yeah.
Just before.
He flatted, right?
Yeah.
Yeah.
20K to go.
Wow.
Yeah.
But he was holding his own. He was in the lead group, or?
No, he was second. He was within like 30 seconds of Schmiel. I think Schmiel was going to win it no matter what. But yeah, if Museeuw maybe still had a chance to bridge up. We'll never know. But then he got flat, and his feet were stuck in the pedals, and took him a while to get on another bike.
What a problem to have, but Paris-Roubaix, anything could happen.
Exactly.
So we'll take this out. I mean, there's him on the bike.
Oh, yeah.
And then here they are assembling it prior to the race.
Oh, that's great.
I can't remember. It was like almost the night before.
The night
Maybe
before.
2 minutes before. I can't remember. It was really last minute.
Must be absolutely crazy.
So if you hadn't already figured it out, Matt's a collector.
Yeah, that's a beauty. 1895?
I think it's 19. You know, they didn't change for a while. I think it's 1910.
1910.
Because the hub is stamped 1910. So and that was actually an upgrade feature for like 50 cents to get a coaster brake hub. But
That's a beauty.
yeah, this one,
Yeah,
it was restored in the 70s, and I did a little work to it, but it looks like it just came out of the factory, right? I've ridden this once, but look at the gear on it. It's like, it's enormous. You got to be going like 40 miles an hour. It's crazy.
It's pretty to look at though.
Yeah.
the whole lineup.
Yeah, this is where Rick figured out my 2,000 different SKU numbers and organized it so that we could tell the story, because it's really helped me tell the story of bearings.
You got the Tour de France racers.
Yeah, got to have a bike race going on.
Yeah.
They move around every week. Different guy in the lead.
Those are Chinelli hubs made by Jim Merz.
Oh yeah. Are they bivalent hubs?
Yeah,
Yeah.
with titanium bits.
Yeah. I saw those on Classic Rendezvous. I couldn't afford them.
Well, now you met the sucker that saved him. This is the 7-Up building, 7-Up bottling plant. And the story goes, they started bottling here in the 1930s and up through the 1990s. And this building, we added that addition there, but this building was the refrigerated section, and this is where they stored all the pop before it got shipped out. Of course, we're using it as a bearing storage area right now, but you can see here there used to be a door here,
Yeah.
and this is where the train would come up to load, because this wasn't here, this building wasn't here. The train would come up along here and they'd load the soda through these doors here. There was a railroad spur right here, and this is where they loaded the pop into. And then this part they built in the 1960s, and then this roof over here was 1950s. It's kind of a interesting building because it's been added on to so many times. So there's the original building, and you can see the external siding on it. So originally it was just that building there, and then this refrigerated building over here across the way with the train in the middle. And then it grew, and by the 1950s and 60s, this was all just bottling in here up through the 1990s, and then they moved it out to the valley. And we got the building in 96.
Wow. Still green and white. That would have been 7-Up colors, right?
That's them,
Yeah.
So we have this is almost all Enduro bearings, tapered roller bearings. All these numbers you see here, these are tapered roller bearings for forklifts and industrial equipment. And if we move over to here, here's some old ones here. These are like, now we're going back a little ways. I can tell by this printing, this is probably 1950s. This is still left over from Matt and Mike's surplus buying bearing days. Some of these Timken boxes are pretty old, and Bauer, these numbers, these are kind of older stuff.
So Mike was working on forklifts before you guys. No, you both came out of the bike shop.
Yeah, but
Handlebar
his dad had a forklift business in New York in the 1950s.
Oh.
And so he was building forklifts too, and he designed some, and then he came out to Emeryville, like right over here in the Bay Area in the 1970s, and continued with the forklift business. So Mike was working at the bike shop, but he was also at his dad's forklift business.
Wow.
Working on all sorts of things. So we have a lot of FAG stock here to carry some other brands in the industrial side besides Enduro bearings, sizes that we don't make. And they get pretty big. Like these are some pretty big, and you get.
Yeah, show me a giant bearing.
Well, I
Wow.
need a forklift to pull it out, but this is a,
Look at the size of that thing.
yeah, and you can see the numbering. This is like 71888, so that's a really big bearing. A 71806 is a bottom bracket bearing, so it's a big sister, big brother of that one.
So that whole number system is something that means something to bearing people.
Yeah, the 7 means it's angular contact. The last 3 numbers are the dimension. You'd take 88 and multiply it by 5 to get the internal diameter. Like a 7806, you go 6 times 5, it's a 30 millimeter bearing.
Oh,
And then 7 means it's angular contact. Like a 6211, 6 is radial bearing, 2 is the series of radial bearing, and you take 11 and you multiply it by 5 and you get the internal diameter. Let me show you over here. So this is what we started with this is a mass guide bearing for the forklift. So this is the bearing that rolls up and down the carriage of the forklift. So this carries all the weight. So when you see the forks go up and down, this thing is rolling in a track. And this one's heat treated, it's chromoly. It's called the tire. So this is the tire that rolls up and down the mast. And then we're gonna put these tapered roller bearings in here. And what they're doing, this is the spacer that they machined for the tapered roller. There's going to be 2, they oppose each other this way, and to get the adjustment you have to machine this to get the preload correct. And so it's like adjusting a cup and cone, except without a threaded axle but with a spacer.
so it has to be just right.
It has to be just right.
Yeah.
So we do that in the lathe in there.
With some big snap ring pliers.
Need some big snap ring pliers. Got to be careful. Wear your eye protection.
It could kill you. The size of that snap ring.
And then that's the seal that goes on
Wow.
at the end. It's a shield, actually, not a seal, but that goes in there.
They press it together with by hand. These are the ones you put right here.
Yeah,
There you go.
hydraulic press right there.
It's actually a giant milkshake machine.
It does look like a milkshake machine.
It's like, yeah, that one's, yeah, we rebuilt that a few years ago, another vintage machine. I think we like vintage machines here, so. So in here is Mike's. This is his lathe that when we started together, he still uses it, but we're using it to make spacers today. But this is the lathe he was using to make bearings when we started the business, this Sheldon. So this goes back to, he was using it in the 70s, working on, so he was starting to make mass guide bearings for old forklifts that you couldn't get them for anymore. And so if he's going to make 2 or 3 for a forklift that's in the shop, he'd make 20 and sell the rest to other shops.
Oh,
So that's how the business started.
that's smart.
That's how the whole bearing business started. Andy was working at the bike shop, but the bearing business, or that part of it, became a business. And then we started buying up, I joined him and we started buying up surplus bearings and reselling them. That's when I learned a lot about bearings. And then I started getting bearings made specific for bicycles. First for hubs, for like White Industries and Cane Creek. They were a couple of my first customers, and then grew from there.
Yeah, it took a while for the bearings to take over, because now they're in everything.
Now they're in everything. When we started, you're right, it was here and there, and then it became bigger and bigger and more specific. Then we had specific bearings for suspension pivots, specific bearings for hubs, and then ceramic came in, ceramic bearings, and addressing design and challenges with that. And headset bearings, of course, and pedal bearings you mentioned,
Yeah.
and bottom bracket bearings. Let me show you over here. There's some. Here's some goodies. There's some 1950s McGill. These are some, when I see these boxes, I know how old they are. I mean, you can tell sort of certain...
The artwork.
Yeah, you know, these metal corners on these things.
Oh,
you
yeah.
know, they're not from today, but this is probably, and the Torrington needle bearings, these were probably made in Virginia in the 50s. But there's a lot more. I'll just show you a little section over here. I promised you I'd show you some more old bearings. Like, this is what we have left of surplus. We don't really sell much anymore out of here, but it's kind of it's become more of a museum.
But they're vintage machines, right? Somebody might need it.
We've got them listed. So
Yeah.
if somebody calls, like they want a Fafner 216 WD, here it is, or an AC Delco rod mill drag brake bearing. There it is. Now there's some really cool ones here that are. Let's see. I'm looking for. Here's a Marlin Rockwell TRW. This is a. It's ball bearing, but I can't see the number on it. But we have them all in the system. We know what they are, but a lot of these are for. I mean, they're still good today if somebody has the old machine that they need them for, or new machines. Sometimes bearing sizes come back and they're used again.
It's impressive. So many.
Yeah, you should. We had containers full of. At one point we had a 40-foot container of surplus bearings. We had to go through that. It took me like 2 years, and you clean them and identify them and figure them out. But I learned a lot about. Let me see if there's a self-aligning bearing. Oh, here you go. Here's this one's pretty dirty, obviously, but it's a self-aligning bearing, double row, like things like this. That it's pretty tricky how it
is tricky.
Holds together, but
Wants to stay there.
they're kind of cool objects.
You can't pull it out.
Yeah, but this is like when you have a shaft that's not going to be perfectly aligned. This thing will take care of it for you, so you don't have to sit there and try and align the equipment in another way. It's self-aligning. This is a max bearing, but it's a max with a retainer, so it's a hybrid. When you say max, it means it's full of balls, no spacers. This one has more balls than usual, and it'll have a fill slot. Oh no, this is a self-aligning max retainer bearing. So there's hybrids of everything. When you start down the road, there's little differentiations of design that is almost endless in bearings. It's fascinating to me. And then if we come over here,
Whoa.
here's a
Look at that thing.
This is a max retainer bearing and double row, 2 rows of balls. But it's cool because you can see the fill slot there. That's how they put the balls
Put them in there.
Hmm?
That's how you put them in.
That's how you put them in. So you'll see there's no fill. Oh, there is one on this side. Sometimes there's none. Sometimes they put the fill slot through the middle, and only one side has it. But this one's got it both sides.
So
Anything heavy, Matt?
No, it's very lightweight,
That's your workout today.
made out of magnesium.
So you push it to the side to push the ball in? No, you do.
Yeah, you would, you'd line it up, and the ball would actually, it wouldn't just fall in. You either have to press it in, or sometimes you heat it up so you can drop it in. So they get it hot,
And then it's a
expand the
little.
metal. This one also has a grease port there, oiling port. So
That's in a vehicle?
this is probably some kind of final drive shaft,
Okay.
either for maybe a ship, could be a ship, or a really large, like, earth-moving vehicle, I would say.
So how long have people been using sealed cartridge bearings in the first place? Way before the bike industry discovered
Oh
them.
yeah,
Yeah.
more than 100 years. Yeah, almost when they started making ball ball Conrad style bearings.
Because the cup and cone bearing, the problem is it's really hard to keep them sealed.
No, you can seal them. I've got some over here. We're putting seals on these. So here's cup and cone, or a tapered roller bearing.
Tapered roller bearing, yeah.
But you we press a seal onto the back here. We make seals for them. We press them on here.
So you can buy seals individually.
Yeah.
Yeah.
And then you can seal it a different way. You just have to account for the design. But so cup and cone you can seal like this. It would be a ball version of this. And you just press a seal on the back. But they take up more room. And then they require people to adjust them. Like cartridge bearings, the play is set, so you just push them in, and the mechanic doesn't have to think about.
Right.
Now they have dead stops, you just tighten it down. And cup and cone, we made a cup and cone. That was the XD-15 bearings we were making here for some time. They were 45-degree angular contact, the bottom brackets. But there were two challenges with that. One, you had to show people how to adjust the cup and cone. And two, the manufacturers not always made it easy for us to make an adjustment system for them. So we went back to cartridge bearings because there was just too many questions
Yeah.
with the design.
Employees only.
What's that? Yeah. Yeah, we left the original signage is. Hey, Mike.
Yeah.
I want to introduce you to Jim Lang.
Hi.
Hey, how's it going?
So this is my partner, Mike.
Nice to meet you, Mike.
Yeah, likewise.
I read
This,
about you.
this is
Yeah,
Dad.
yeah, yeah.
Good, how are you?
So just giving him a tour.
Sure, sure.
And you guys worked in a bike shop together
Long time
back
ago,
in the
yeah.
day. Handlebar, right?
Yeah. I was-
Do you remember that shop?
No, I remember the name. Very impressive
Thank you.
what you have here.
Yeah.
I mean, had no idea bearings were so, I mean, 2 warehouses and just incredible.
They use a lot of them, yeah.
Yeah.
Yeah. And we're small, like little, compared to the whole industry. This is like, I don't know, we account for like this much of product that's available. There's just so many different things.
Well, I mean, one way to look at it is if you look at a bearing catalog, like this is by no means a comprehensive catalog, right? This is a partial look at the industry, and we maybe account for 4 pages out of this, or maybe 10 pages at most, in terms of what we have here.
And what you carry.
But there's like the whole bearing industry is probably like 10 of these, or maybe more. I mean, there's bearings that we've never heard of, in a sense. So,
And you choose the bearings that, for the applications that you're
Yeah.
involved in.
sure,
Yeah.
bearing industries, yeah.
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 Yeah, very niche product. Like, for instance, material handling on one side. We do a few other things too. Like lately, it's been more drilling applications that Mike's been involved.
Yeah, I mean, if you've seen the bearings at his place, but like, see that red box there? That's one bearing. The history of ball bearing mechanized production is very much tied up with the history of the development of the bicycle. Like the first ball bearings that were produced in quantity were for the bike industry, like in the 1880s, or when it was first getting started. Because that was the first machine, before cars. That was like the first transport machine that was in any kind of production. So it is kind of, those two industries go back a long way together.
Yeah, Aeolus hubs. I think they were the first production bearing.
Oh yeah.
Well, that's the one I remember.
Yeah.
There was a couple
FAG claims they invented the first machine to mass produce balls.
Right.
I don't know if I don't know if they really did, but
Mr.
Fisher.
Fisher, that's right.
And that was for, I think, for pedals.
Yeah.
Just I don't know how they made balls before that. Probably on a very small
Yeah.
basis.
I mean, I've seen like rolling them, but forging them for sure.
Well, that's how they used to make like shot.
Right, exactly. Yeah.
With those shot towers, but that's out of I don't know if you could do that with steel. That's an interesting point. You know, because they just drop it, and it would, on its way down, it would coalesce into a ball and then fall into a basin of water.
Yeah, it'd be interesting to see like what was their original process if they were casting and then somehow making a more perfect sphere.
Yeah, I just don't know if you can cast steel so small.
Right.
That gets back to the chicken and egg. Who made the first mill to make the first bearing?
Yeah.
Because you got to make, it's a chicken and egg thing.
Yeah, you need a bearing to make a bearing.
So between you guys, who's the chicken? Who's the...
I don't know.
That's like the first lathe, right? You need a lathe
Yeah,
to make a lathe.
the first lathe.
Yeah.
The first ruler.
The first one's got to be made by
You need a ruler.
The first ruler.
You need a ruler to make it.
We need a ruler to make a ruler.
Jim Mers made the first lathe. That would be the type of guy. Guy who made those Chinelli hubs.
Oh yeah.
Good insight. Now you got us like, now we're gonna.
Nice to meet you.
Likewise.
Yeah.
Thank you.
Pleasure.
What you hear humming in the background is the test machine, which I've been running since this morning because it needs to heat up, warm up before it gets to sort of a equilibrium of bearing grease getting warmed up and windings getting warmed up in the motor, and so I can get some decent numbers. So I was just going to show you today kind of a basic run through of the test machine and what we do, because so we test bearings for longevity. So what I'll do is usually this particular, you see there's a shaft here with two mounted bearings.
Yep.
And then there's this one. This one is just my run-in one. So I use this to run the bearing into, let's say, 1,000,000 cycles. This shaft has a strain gauge in it. And if I turn this on, you'll see some wattage numbers. So it's got a wattage or a strain gauge in the middle. So I can get the relative power absorption of this from the motor. And then I'll show you how we isolate the bearing from these two bearings, which is supporting the entire shaft here. So this is just wattage that the motor is using here. And there's one other piece on here I'll show you, but let's just talk about the wattage first. So as I've said before, is bearings use very little wattage. That's one thing. It's really hard to measure it because it's actually about 1/4 watt or 1/2 watt, and most meters only measure in full wattage numbers. So as this one is showing 12 or 13 right now, see what it's kind of flipping back and forth between 12 and 13. Now this is the bearing I've been testing, which has about 500,000 cycles on it so far. And if I hold the bearing, this isn't changing at all. I'll let it go, and now it's just turning with this. It's still kind of jumping between 12 and 13 watts. And then I grab it, so that's the resistance of the bearing. Should show on the strain gauge, but still you're getting 12, 13 watts.
Right.
So that's kind of the story there. It doesn't give you full numbers. So to get full numbers, we got to load the thing and amplify the load. So I have, this is going to put a radial load of about 20 pounds on the bearing.
Just the weight of the bar.
Yeah, change it a little bit. And then I also, I also have a thrust load of about 20 pounds from this side. This lever is about 20 pounds of power on there with no weights on it.
Pushing laterally.
Exactly.
Yeah.
So a thrust load and a radial load. And so the combination is an axial load. So now we get a difference in the numbers. Now bearing in your hub usually never gets that kind of constant load. That's a lot for this size bearing. But we go even further to amplify the load on it to see what the wattage change is, and then we can do side by side with other bearings and get full wattage numbers and see what's happening between bearings from other brands or our bearings with different designs. So now I'm going to put a weight on here. Just going to bring it up. Since it's out here, it's a 25-pound weight, but it's about 60 pounds radial. And then I'll put these guys on, because I know they'll give me about 20 pounds thrust. Now we're up to about 20 watts of usage. So that, we were between 12 and 13 before with no load on it, and the bearing just spinning. So it's using about 7 watts right now, this bearing. And that's how we isolate the amplified wattage numbers. Now there's other things that this machine tells me. This is a vibration meter gauge, and I'm going to plug this in. It's got a magnet, and I put it on as close to the bearing as possible. And what this is measuring is the internal acceleration, if you will, of the balls, like momentarily maybe sticking and then moving on, which we can't see, but it's happening. And when it's very low like this, it's really smooth. The bearing's really smooth. When it gets up to 1, I got to start to worry that the vibration, the bearing is getting rough and it might blow up. I got a dead man switch, so if the thing failed, the whole machine would stop.
Just turn off. Yeah.
It won't drive itself into the ground or something. But that motor's pretty powerful. But so this tells me how smooth the bearing is still. And when it gets up to, let's say, 8, I know it's galling. Like the ball is actually starting to pit the races. And that's what happens in bearings. The ball starts to break out little teeny microscopic chunks of the bearing race. It actually starts with micro cracks, little teeny cracks in the bearing race, and then eventually those turn into like little potholes in the road, like you run over with your car. And as the tires keep running over it and over it again, the pothole gets bigger. Yeah. So that's galling that happens. The eventual failure of
destroy it. Yeah.
So now let's go back to this, and I double check myself that we're still at 0. So kind of jumping around about 20 watts. Now I'm going to unload it. Take the weights off that side. Take the weight off this one. Sorry, I have to cross back.
That's okay.
And then I unload the thrust. And I unload radial part.
Wow.
And we're back.
We're right back
to about 13 watts.
No effect on the bearing at all.
Yeah.
So you would test the bearing in here for longevity, or?
Yeah.
Yeah, you do.
Yeah, so we run it like this bearing, this bearing's been up to 1 million cycles now.
1 million cycles.
That's an XD-15 bearing. Still feels pretty good. That's kind of usual results with these. A lot of bearings won't make it to 1 million cycles, but I'm going to go through, and these are all different brands, and test different 6902s. It's a real common hub bearing, and it gives me a relative sense of our bearing compared to other people's bearings in the competition. Let's say the other brands and how they stack up to ours. So.
How long will the machine run? You just leave it running?
I let it run, usually not overnight, but all day while people are here, every day. Wow. So in the morning it starts up, and when we're running in bearings, we don't have to wait for anything to warm up. When we're testing wattage, we got to have temperatures exactly correct and even all the time, because 1 degree of temperature here can change the wattage results. So when I'm checking wattage, it's usually in the afternoon, and I have to have everything the same temperature in this room. That's why there's this heater over here to heat this table.
Oh yeah.
And so temperature change has to be the same. But when we're running bearings in, we just start it in the morning cold and run it until we leave at night. So 8-9 hours a day.
Wow.
And because it takes, you have to get to a million cycles, you have to get to 167 hours.
Wow,
So
167 hours.
Weeks. And actually our last bottom bracket test, it took almost 2 years to get all the data. Like, because you can't just test one bearing either. You gotta test a couple other, because there might be something wrong with one of them or something right. So you have to get averages. So it takes a long time to test all this stuff. I know this machine too well. I've spent more time with it than some of my friends. A couple other things, we're running at 100 RPM on these bearings. Here's the hour counter here, so we're at 84 hours.
And you invented that machine.
Yeah.
A work in progress?
Yeah, it is. It's changed because the wattage meter at this end was new. We had to make a special piece for the bottom bracket. We use a bottom bracket with a strain gauge in it, and we had to copy the splines for the piece that holds the bearing on the end, like we did the 6902. So, but yeah, it's evolved over the years. And this machine was developed for ISIS bottom bracket bearings because they were failing left and right, and people were asking me to make a better ISIS bottom bracket bearing companies, and so I needed to know what the benchmark was, like what is the place where the typical ISIS bearing fails. So I built this machine for that with the help of a friend of mine. We came up with the simplest idea possible for testing bearings. And then we were able to build some better ISIS bearings, and about right when we did is when everybody dropped ISIS. Shimano went to the outboard thing.
Yeah.
So, but I learned a lot, and then I started testing Shimano bearings too. But the good thing about the design of this thing is there's not a lot of interference. There's not a lot of noise. There's some bearing testing machines that have rubber belts or other things that change too much over time, that makes too much interference or noise would make too much noise in the wattage numbers, because this is about as simple as you can get with as few moving parts as possible. We can actually isolate bearing wattage because it's very difficult to measure. I used to talk to Steve Head, who was testing forever with aerodynamic wheels and rubber, the tires and the friction from that. And I go, I'd ask him my early days, hey, how can we get bearing numbers out of that? And he's like, it's so far down there, Matt, you'll never find it. It's like, it's part of the room temperature changes 1 degree. He was the one who was telling me some of that stuff. I was talking to other people, and they're like, yeah, it's theoretical, but measuring it, you're not going to be able to. So the only way we were able to measure it was by amplifying the loads. And I did get people's, some professionals' agreement on the subject that this is actually correct, that it's working, but it took a while to get here, like probably 20 years.
Wow.
To get to this point.
Well, you brought it to Sea Otter, didn't you?
Yeah, we hauled it out to the water on here.
That was pretty cool.
But people were more fascinated with the aquarium than the test machine. Aquariums are, with the lights and where's the fish? It's more of of an interesting display than this. Corrosion's a good story too. That's the whole thing. I'm not going to pour salt water on this thing.
Yeah.
But that's the other part of the story. You gotta, because corrosion accounts for 95% of bearing failures. Sweat and sports drinks.
Yeah.
And then the frame, the way the frame is, you have 4 tubes headed towards the bottom bracket. It's perfect drainage system for sweat, sports drinks, salt water, everything to go to the bottom bracket. So that's the main area of
concern and corrosion failure is in the bottom bracket area. To wrap up this epic day at Enduro, next Chris will be installing Enduro's ceramic hybrid XD-15 bearings in my hubs and an XD-15 bottom bracket too. I was able to film some of this so you can get an idea of Enduro's impressive selection of bearing pullers, presses, and hand tools you can see in these slides here. And listen to Chris talk a bit about how they're used. XD-15 bearings are an Enduro exclusive. There are some details in these product pages. Enduro calls them the pinnacle in bicycle bearing technology and explains what makes them so special as follows. XD-15 bottom bracket and hub bearings combine silicon nitride grade 5 balls with an advanced nitrogen-infused aerospace stainless steel bearing race that will never rust or corrode. The bearing race is so tough that should grit find its way through the double lip labyrinth seals to the inside of the bearing, the surfaces will not pit. The grit actually polishes the bearing races smoother. Guaranteed for life, Enduro XD-15s are the last bearings you will ever buy until you N+1 your inventory.
I'm just making sure I have everything correct. Just do a remove and replace on your BB here. Looks like GRX 11 speed. I'm a little bit familiar with GRX 11 speed, seeing as I have two bikes with GRX 11 speed on them. This is one of my favorite tools, this little thing. It's just a simple little thing, but you know, I take my crankstops off and I always keep that tool right there in my toolbox or on my tool stand because I'm constantly reaching for it. Spacers are not really something that is necessary. There she goes. It tells you what you got. It's beautiful to look at, but no one's ever going to see it. And this is a standard 52 millimeter by 16 spawn. I just like to get them hand tight first, make sure everything's seating properly. Make sure that center sleeve feels like it's engaging right now. That seems good. There are nice logos on there, but you'll never see them. Beautiful. Okay, just like, and so these are, as I said, angular contact bearings. So I like to turn this down till it's pretty darn snug in my hand. You want to have a little bit of an axial load on these bearings to engage all the balls. I like to go in and make sure I flattened out those seals a bit, back it off a little bit. I know it's tight on both sides, and then just crush those seals maybe 0.5 millimeter or so. And that should give me the proper load that I need for these 15-degree angular contacts. Check your shifting. So bottom bracket is complete. Front hub, we already did the rear. Okay. This is a feature of our, what we call our BRT 222 slide hammer tool. It's got this head that has the same threads as our pullers.
Oh, look at that.
So you can use this thing as a mallet. You've got a couple different types of heads that you can put on here, but the bonus is that
fits the Shimano tool real nice, and it's got some magnets in there so it doesn't fall out.
It is nice.
Convenient. That size. Yes. Another use for these blind hole pullers is really convenient for pulling your end caps off. It gives you something to hold on to.
Yeah, I didn't even think
Really-
you could do that. That's clever.
And again, this is the standard issue pullers that we're using for this same kit, which we call the BRT 222. Good. There. And I'll use the same one on this side. Easy peasy. All right, so pulling these bearings out, these axles have stops on them, which is really convenient. This cup sits right onto the center lock line, and with the aid of the axle, I just use a little guide that just sits right in there to keep everything centered. I can use this same cup. Again, this is part of that, what we call the BRT 040, the BRT 40 kit.
It's pushing it out.
And it just uses the axle to gently push the bearing out instead of having to whack the axle
Pound on the axle. Yeah.
with a hammer. Here's the common solution. But boom, it just comes out nice and easy. And then I just flip the axle around and did the same thing on the other side. They've made up together. Give you a little extra. This side, this is actually designed for when you're removing the bearing from the drive side, and the axle is so long, sticking out. So it's designed the same way, just to give you an extension to pop both of them out. Here we are. Okay, again, we're popping these bearings out and putting in some XD-15s.
These are the green.
Again, the green seal. Let's
Yep.
see if I remember which way. This thing looks pretty symmetrical, but it looks a little bit rounded up. So I'll go that way. Put number 2 in now. Going around that axle. The cup. You see the cup just, it's rides mostly on the outside race. That's what we want to use to drive the bearing in. Okay, our fancy nut there. Now, you can see this is a little bit different than this side.
Yep.
This side of the press has a needle bearing on it. It's a thrust bearing, so it's designed specifically for this test. It's like a lazy Susan.
Sure.
And it just, so you can just hold this side and spin this side and everything stays static. There's no spinning on the tools or spinning on the bearings or on the hub. And nice and smooth. Boom.
Chris is the ideal person to do this upgrade to my bike because he helped design and develop many of the Enduro tools he's using. In closing, I want to thank Chris and the entire Enduro crew for such an awesome visit. I learned a ton, and I bet you did too. Along with the XD-15s in my hubs and bottom bracket, Enduro also gave me XD-15 bearings for my headset and a set of their direct line pulleys, which I'll install in my shop. So be sure to watch for those episodes later.